So our objective today is to understand theorems, dealing with inequalities, for one triangle. Okay, understand theorems dealing with inequalities for one triangle. And this is lesson 6-4. It's a good idea to read through the book. All right, so we got a series of theorems and corollaries. No postulates. So theorem 6-2, no name. This one says, if one side of a triangle is longer than a second side, then the angle opposite the first side is larger than the angle opposite the second side. So again, we're focusing just in on one triangle and two of its sides. Okay. All right, so let's go ahead and we're going to draw a triangle. And I'm going to number my sides. 1, 2, 3. And I'm going to label angles A, B, C. Actually, let me rearrange some numbers just so it'll kind of match. Oops, come back here. Let's call him 1 and let's call him 2. Okay. So this is saying if one side of a triangle is longer than a second side. So in our drawing, if BC is greater than AB, what it's saying is the angle that creates that side has to be the angle opposite it. So what creates that side is this angle A. So we pair up measure of angle A with the length of BC. And the second side is created by angle C. So we're going to pair up AB with the measure of angle C. And what it's saying is that the side that's longer has an angle that created it that has to be larger. So the relationship maintains the same sort of relationship from the sides to the angles that created those sides. Okay? That's all this theorem is saying. I'm going to change him to black. Okay? So angle or side BC is created by angle A. Side AB is created by angle C. Because BC is longer than AB, that means angle A had to be larger than angle C. That's all this theorem talks about. Does that make sense? Clear as mud, right? Okay. Ready for your next one? Moving on. This one, theorem 6-3. If one side of a triangle is larger than a second, oh, sorry, angle, blah. This is one angle. I'm going, wait a second, I'm writing the same thing over again. If one angle of a triangle is larger than a second angle, then the side opposite the first angle, the larger one, is longer than the side opposite the second angle. Okay. So again, this would be, and again, we're not going to, this is not part of what you get to write down, but you can tell this is the converse of Theorem 6.2. Okay. So let's see if I can draw this. So I didn't want to draw one angle that's larger, so I'm going to do an obtuse angle, so there's no fooling around with that one. And then let's shorten this guy a little bit. And then we have this. So that's angle A. Let's call him angle B, and we'll call him angle C. So if one angle of a triangle, let's say measure of angle A. Oh, I always do that backwards. Is greater than a second angle, let's call it measure of angle B. What we're going to do is pair up the side that's created by that angle. So again, angle A is creating this side. So this pairs up with side BC. Okay, just need to take a quiz. Right there, probably is the best spot. Throw the backpack off the chair. Angle B forms this side. So we get side AC. So according to this theorem, the relationship that exists between angle and side is the same. So if measure of angle A is greater than, oh boy. All right, so let's try this again. So the measure of angle A is larger. We can see that. The side that corresponds to measure of angle A, the side that's created by measure of angle A, is side BC. Shh. We know that measure of angle A is greater than the measure of angle B. And the side that's created by angle B is the side AC. So the relationship that exists between the two angles, where A is larger than angle B, exists between their corresponding sides, where the length of BC has to be greater than the length of AC. Okay? Now we got two corollaries to this particular theorem. So corollary 1 to Theorem 6.3 states this. The perpendicular segment from a point to a line is the shortest segment from the point to the line. Okay, so the perpendicular segment from a point to a line is the shortest segment from the point to the line. So we've got a line, we've got a point. Now I could draw all sorts of different lines from this one. I could go way over here. I could go like that. I could do kind of mirror images on the other side. And can you notice, of the lines I just drew, which one is the longest? The outside red ones, right? Because it had a farther distance to travel, okay? And then if I drop straight down, making it perpendicular, can you see how that blue one is definitely the shortest one? Okay. And the reason why it changes is it has to do with the size of the angles that are created. Okay? We have right angle, which creates a right triangle, which by default, the side opposite the right angle would be either the green one or the red one, depending on which right triangle I would be looking at. So that's always going to be the largest side. Okay? The other two would be basically, and I know the green one's not the best one to look at. If we look at the triangle that's formed by blue and red, the blue line is going to be shorter than the other because the other two angles have to add up to 90. So you're going to have one that's over 45, you're going to have one that's under 45. So the angle that creates the side is this angle here. This is the angle that's going to create that blue side. And if you look just solely on, let's get rid of the green guys, get them out of our way so we can see things a little better. Okay. You can see how this angle is smaller, I'm sorry, not shorter, than the angle that's coming from the top, the vertex at the top. So that's why we're going to get a smaller one, okay? All right, we got another corollary. Let's add him. Corollary 2. To Theorem 6.3. And this one says the perpendicular segment from a point to a plane is the shortest segment. From the point to the plane. So this is not a converse. This is different, dealing with a different situation. The top one is having that point going to a line. The second one is going a point to a plane. But the same relationship that you see going on in the first corollary would be the same in the second one. So if here's your plane, and here's your point, what they're saying is this is the shortest distance from the point to the plane. Every other distance to the plane is going to be longer. And we've talked about the fact that the perpendicular is going to be the shortest segment. I can't remember what chapter that was. I think it was in 4. So much of what we've talked about has been in 4. Okay? All right. We've got one more theorem, and this one has a name. Everybody good? Or do you need to wait a minute? All right, last one. Theorem 6-4, whose name is the triangle inequality. So remember in proofs, and I still had some people doing this on the test, if you have a theorem with a name, use the name. It's universal. Everybody understands what that guy's called. And this one says the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So they do give a proof behind this one, but this is just basically saying this. We'll call this triangle ABC. And from this theorem, we get three statements. The length of AB plus the length of BC will be greater than the length of AC. So this looks like a right triangle. If it was, the two legs would add up to be greater than the hypotenuse. If I added AB plus AC, so a leg and the hypotenuse, it would be greater than the BC. If I added BC, the longer leg, and the hypotenuse, it would be greater than AB. Okay. And you're going to use the corollary 1 to help you with this type of proof, because you're going to create a perpendicular line, creating it to be the shortest distance, so that you can do a comparison, and that it would be that shortest distance would be the smallest one. So anyway, it would be really, that's how they go about it. It's, you actually have to prove, in something like this, you actually have to prove all three cases in order to prove this theorem. But for us, we're just going to use it. So you'll be seeing stuff like this on your homework tonight, and that's it.